We're going to add some stuff to that graphing. I will not see you guys again until Monday. So the worksheet won't be due until Monday. And then on Monday we will continue with graphing stuff, but we'll also talk about inverses. And then we will be going from there. So, does everybody know where we're going?
What about Tuesday?
Tuesday we are learning something new, and will you not be here?
No, I will.
We'll do rate of change, average rate of change with our graphing after this.
It's kind of chilly in here.
All right. The parent function. We have a parent function of every function. We know that the parent of a line is equals y equals x. Y equals x is the parent. The basic function that keeps the same shape of that function is known as the parent function. Exponential parent functions are a little bit different than always being y equals x. There's like families that are happening here because it's dependent on the base. So for example, this is the parent function for the family of base 2.
Did you say family because it's called a parent function?
Yes. That's the only reason why I'm using that word. I don't know, honestly. If it was like something like this, you see my base is 1/2. My base of my exponent is 1/2. That would be the parent for the family with base of 2. Or base of 1/2, sorry. So these are just examples, by the way. This is not like the end-all, be-all. These are just some examples. Just let me know, okay? Okay, so what is the parent for this family? 3, so it's the base. Do you guys all see that? Yeah. So the parent for families of base 3. Okay, so what you'll notice for the parent function is that the parent function is different based on the base. You guys understand that?
Yes.
But the parent function will not have anything multiplied out front or added or subtracted at the end. Again, the parent will not have anything multiplied out front or added or subtracted at the end. The parent will not have anything multiplied out front or anything added or subtracted at the end. You guys all understand that?
Sure.
The parent, though, is going to be different based on the base. All of the parents will, though, be stripped down, meaning there's nothing in front and nothing added or subtracted at the end. All right? We got that under control.
Yeah.
This is one of my favorite words in math. It is called an asymptote. I don't know. It's just such a funny word. So this is the asymptote. The asymptote is an imaginary boundary line that the function will get infinitely closer and closer to, but will not cross. So why is that happening? So let's think about an exponential decay function for a second here. So let's make a table. If I give you this exponential decay function, okay, and we plug these in, if I plug in 2, if I plug in 1, if I plug in 0, this is what I'm getting. Do you guys see how? Why is it getting bigger? That's not what I wanted.
You have to go to school longer in college if you want to be a math.
Oh, I know what I wanted to do. No. I just chose the wrong numbers. Okay. Okay, so if I put these numbers in, type 3 into your calculator. Not 3, but do 1/2 to the 3rd power. Just type the number 3. Type 1/2 to the 3rd power and tell me what you get. What do you get when you type 1/2 to the 4th power? 16. What do you get when you type 1? Okay, what do you notice about these numbers?
They're getting smaller and smaller from 1.
They're getting smaller and smaller from 1. It's because I made a really bad table, and I decided that positives should go up instead of down like we normally do. I apologize for my madness. But the point being is that as you're going farther to the right, do you guys notice the numbers are getting smaller and smaller? Will those numbers ever reach 0?
No.
You're multiplying this by 1/2 each time, right? 1/2, 1/2, 1/2, 1/2, 1/2. If you're multiplying something by 1/2, can it ever get to 0?
Yes.
What's the only number that you can multiply something by to make something 0?
0.
0. So there is no way to make this 0. That is why there is the silly word asymptote involved in this. The asymptote is the line that it will not cross. The asymptote will move. The asymptote will move around, but there will always be a line that it will not cross. So we say it won't reach 0 or it won't reach -4 if the asymptote's there because of how the graph is moving. Do we all understand that? Okay, so the asymptote, just so you guys know, is always a horizontal line. Horizontal, horizon.
The horizon.
The horizon is left to right.
Yeah, that's fine.
Is always a horizontal line, which means it's always a y equals equation. So it's always y equals a number. Okay, so get that stuff written down, and then we will look at the next page.
Looking at next page, commencing.
Yeah, one piece of. No.
Guys, okay, we're going to take a step back for a second here. I need to have... So, we are going to graph y equals 2 to the x. So we know that means we're plugging in -2 for x, -1 for x, 0 for x, 1 for x, and 2 for x. So go ahead and start typing those into your calculators all by yourself. I'm not going to put anything in my table until I start seeing people writing down stuff in their tables with the outputs.
What if you already know how to do it?
Then write them down still.
Okay.
I want to see some outputs in that table. That is not -4. Put it in your calculator, please. Let's go. If you need help because you have no clue what you're typing into your calculator, let me know. Did somebody say they need me? All right. So you should have gotten 1/4 or 0.25. Those mean the same thing. Which means this is the ordered pair, -2, 0.25. All right. The next one here is 1/2 or 0.5. So that would be -1, 0.5. Then you should have gotten 1, 2, and 4. So this is 0, 1, 1, 2, and 2, 4. Do we have questions on this so far?
No.
Okay, so this is where you're going to find the asymptote. So there is something that is being added or subtracted at the end here. Do you see how there's nothing being added or subtracted at the end here?
Yeah.
So this is like +0 here. Whatever is added or subtracted at the end is known as the asymptote. At this point, our asymptote is at 0. So we have an equation of an asymptote, and we're always going to draw that line in. So we know we don't need to cross it. So that's our asymptote at y equals 0. It's always a y equals equation.
Is it always going to be y equals 0?
No. It's going to be y equals whatever is added to the end of the problem.
The y-intercept? Like how you find the 0 on the x, the asymptote is what it
No.
matches on the y?
No. Okay, and then go ahead and plot your points. We'll look at different problems so you can see it too. So we notice, do you notice how I'm dragging my line along the asymptote? If you cross your asymptote on your homework, I will mark it wrong. It should not cross the asymptote. It should be reaching the asymptote.
If you cross it by accident.
I don't know if it's an accident or not, so I'm going to mark it wrong. I can't read your guys' minds.
If I tell you it's an accident.
Well, then you can erase it and fix it. Well, then you shouldn't have used pen. All right. Put your phone away. This is what I'm talking about. So, domain. I don't care. Put it away. Domain. Who remembers what domain means? Yes. It's the x value. So it's our values from the left to the right. Left to the right. So what is my farthest left value? Yeah. Yeah, it's going to the left forever, so that is what, Tanari? Is it going to be going to the right forever?
Yes.
So it's negative infinity to infinity. What's another word you can use that means that? Who said it? What did you just say? That's all real numbers. Okay, your range is not actually that difficult once you understand the concept. So before we get started, and Mike, you'll answer the question in just a second, okay? Just 1 second though. What does range mean? And that's not the question I want you to answer. Riley.
The y value?
It's the y value. So it's our lowest y value to our highest y value. What is our range, Mike? Is 0 included on our graph? Do we ever hit 0? No. So we always use round brackets. Or we could say y is greater than 0. That's another way to look at that. Yes, we are going back to this. Here's the reason why. Where do you see the number 0 in the equation? Great way of saying it. Perfect. It's an asymptote. So the asymptote is going to be your range. It will tell you exactly where your range is. It will always be from the asymptote to infinity because we are not reflecting exponentials this year. You will do that in Algebra 2. So as long as you know where your asymptote is, you can say from your asymptote to infinity or y is greater than that number. Do you understand what I'm saying?
Yeah.
Okay. Is 416 one of your graphs, one of your solutions? So you could check that by plugging in 4 for x. So plug in 4 for x and see what comes out.
Yes, it is.
It did come out as 16?
Yeah.
So this is yes. So check the next one. Is 2 negative 5?
No.
No, that should be 4. 4 does not equal. So that is not. Okay, look at this and see if you have questions on the graphing at all. Or if you have any questions on the domain and range so far. Jordan.
I lost you at the last part.
These two?
Yeah.
Okay, so all I did is look at the...
No.
Jordan, so what I looked at is I just looked at the x value and I plugged it into the original problem. And I saw if my output came out as that. So we did 2 to the 4th, which is 16, so that is on the graph. And then when you do 2 to the negative 5th, or 2 to the 2nd, it's actually 4. You don't output negative 5. So if you do 2 squared, that's 4. They're saying the output should be negative 5. But it's actually 4, so those two are not the same thing, so that's why that one's not on there. Yes?
Since we did this little equation thing, do we not have to answer why?
This is y. These two things do not equal each other.
So I don't.
And this is y because this equals 16. You have explained why by doing that work. Yes. All right. Start your tables, please. Do you guys think this is going to be exponential growth or exponential decay? Decay. Our base value is between 0 and 1. I'm walking around. I'll see in a second. That first one is not right, and the second one is not right. I think you switched them. Not you, Riley. I just happened to be touching your desk when I walked by. Sorry.
Oh, I didn't.
This is so hard. Yeah.
No, not this.
This bathroom.
All right, so let me put the numbers in for you now that you guys have had a chance to try it on your own. If you don't get them, you should be letting me know. Did anybody not get those numbers? Remember, 1/2 is the same thing as 0.5, and 1/4 is the same thing as 0.25. So if you got either of those, that's fine. Okay, so we look for, yeah.
Can you put them in decimal?
Yes. So 1/2 is the same thing as 0.5, and 1/4 is the same thing as 0.25. Okay? What is our asymptote? It's adding 0. So we have a line at y equals 0 for our asymptote.
So,
It's not always 0. It just happens to be 0 again. We will talk about it.
so how do you find
The one is like adding or something else on the next one.
Adding.
Yeah, the next one will have a different asymptote. We'll go from there. Just let's
how
continue.
exactly
It's
do you
like
find
plus
it there?
B,
It's just whatever is added to the end.
yeah, like your extra stuff.
So nothing is added at the end, so technically it's 0. Do you see?
Oh, so like
yeah.
it'd be -1.
Yes,
Okay.
there you go. All right, so go ahead and plot your points. Remember, do not cross the asymptote. The asymptote is its boundary line. It's not allowed to be crossed. It just glides along it. We'll never reach that asymptote. So our domain values, Jayla, what are our domain values? Negative infinity to infinity, which is the same thing as all real numbers. You can write either or on your homework. I do not care.
Do you have to write the ordered pair form? Or can you just write all
That's
the-
technically not an ordered pair, so don't say that ever again. That is an interval.
You know what I meant.
I know it looks like and I understand why you guys say it, but it is not. So
But can we just write all real numbers?
you can just, yeah, you can do one or the other.
So range would be
Just 1 second. What'd you just say?
Is like what's the symbol? Is that like the, no, that's something in commerce.
Is it like this?
Yeah.
that's the number.
It's like a
That
T.
means number.
No, that's
No, I
not.
thought it
That's
was
the
like
hashtag.
An R, like an I, an R.
Oh, you're saying like the
symbol.
symbol.
Yeah, that's
That's-
what I was talking about. The I,
That is
the R.
IRT.
It's not IR, it's just
I-
R
it
with
looks
2
like-
lines.
I know, it looks like.
All right, so Justin, what's my range?
0 to infinity.
Yeah, the asymptote starts at 0, meaning it will never go below 0, but it will also never reach 0, so that's why we use the round bracket, and it goes up forever. This is the same thing as y is greater than 0. I'm using y because it's the range. Yes?
So with the ranges, can we we put y is greater than 0 on our homework, or do we have to put that in our
You can do either or.
Okay.
Okay, is -2 4 on the graph?
No.
Yes.
That does equal 4, right?
Yeah.
So that's true, so that is on our graph. What is the equation of the horizontal asymptote? We've already written on this piece of paper. What is our equation, Riley? Horizontal lines are always y equals
0.
And in this case, it's y equals 0 because we find our asymptote up here. Okay. Listen to me. Everybody will be fine with plugging it into their calculator except one person. For the next one, you can type it exactly how you see it. I will have to work with you for a second here. But the next one does have subtraction at the end. You guys see that?
Yes.
Yeah.
What does that mean?
That's your asymptote.
This is our asymptote. This time we have a horizontal line through -1. This is the line we will not cross this time. Okay, all of you that have any of the calculators that you have besides what Jana has can type this exactly how you see it. Some of you guys have like Casio calculators that when you raise it to the power, it goes up into a box, right? Just make sure you scroll out of that box before you subtract 1. Everybody else can just type it how you see it. So I'm going to type it, show you how that would look. You're going to do 3 raised to the -2 minus 1. So this is the negative button, and this is the subtraction button. So I'm going to put the first answer up here.
I got a weird number. Whoa.
So that'd be 1/9 minus 1.
That's a big number.
Yeah.
Yours fine. So that's -0.89. No. Maybe. All right. If you get that, you're good. If you didn't get that, let me know, and then I will help you from there. Did you do it yet? No. You should be able to type it in exactly how you see it actually on this one for now. Until we, so do you see how I'm just typing it exact? So hit equals and then minus.
I don't like this. I like
One.
I like math.
Okay. Okay.
I like 2 plus 2.
So get those numbers in your boxes, please. If you don't know what the heck is happening, let me know. That means you should be trying. You shouldn't just be sitting there.
So should it be like this?
Perfect.
Alright.
Just letting you know.
0.666666.
Which is I switched to 0.89. Yeah.
I know. I think I did.
1/3 minus 1 is -2/3. Did you get negative? Okay. Just want to make sure I was doing what I was doing. Right.
You can't log them up.
It's just one off the graph. I know. But you could, it's fine. Okay, guys.
That's what my old teacher used to do. Yeah, I didn't like it. He made me sad.
All right. So we go to plot our points. -2 comma -0.89, that's almost -1. So we plot that pretty close to our asymptote. -1 comma -0.67 is 2/3 of the way down. Then I have 0, 2, and then 8 is 1 off this graph because I think there's only 7 lines, so it would be up here. Is this exponential growth or decay?
Oh, that's growth.
It is growth. Very good.
Good job, Connor.
Thanks.
We come back to this class after lunch, right?
Yep. I'm hoping to have the
What time are we
notes
going
done
on?
before then.
11:46.
Huh?
11:46. Oh, I thought it was 12:06. I was like,
Oh, that's normal
For
days.
you it is.
Okay. Connor, What's my domain?
All real numbers.
Yeah, it's going to go to the left forever. It's going to go to the left forever, and then it's also going to go to the right forever, which is all real numbers, or negative infinity to infinity. I don't care which way you write that. Brian, what is my range?
It's
Stop.
it's the same, right?
It's based off the asymptote. What is the lowest possible point this is approaching?
0.89.
Look on your asymptote. What is your asymptote?
-1.
Your lowest possible y value is at your asymptote, which is at
-1.
-1. But it's not included, and does it go up forever?
No.
Yes, it does. So y is greater than -1.
Wait, why did you put the 8 above the graph? 8 fits on the graph.
Are you counting from the asymptote on accident?
I was counting from the other.
Okay, what is the equation of my asymptote, Alyssa?
I know this one.
Yep. All right. Questions on that one before we do the next one?
No.
Okay. Go ahead and start typing that into your calculators, exactly how you see it. Get some numbers out. Somebody please raise their hand too and tell me where my asymptote is this time.
Positive.
Kaylee.
You're not Kaylee. Positive 2.
Thank you.
Oh, got it. Let me know. Did I get that stuck in people's heads?
Are we gonna have to
Yeah.
scale our graph?
We'll talk about that in a second. Just start getting your points, please.
It's time to pay attention. I mean, I was paying attention before.
Okay, guys, is this going to be exponential growth or decay before we start plotting it?
Decay.
Decay, our base value is less than 1, between 0 and 1. What?
I did all this.
On the wrong pages again?
No, I did that one on this one.
Just rewrite the equations on the right ones. It's the same types of questions for the most part.
Yeah, we should.
I do have a pencil.
Yeah.
Oh, I think.
Oh, I'm so hungry.
You were close, you dropped it.
I almost dropped it.
No one is dead.
Do you want to be my favorite teacher and let me go to lunch 13 minutes early?
No,
No.
I don't care about that.
What's 1? How did you get 1?
I don't know where to go to for math.
Because I never added 2.
Who should I go to for math?
Oh, really?
I did 1/3 of the 0 power and then never added 2. All right, so. You guys.
I think you need to like.
No, that's a very important question, actually. It's about my grade. It was very-
She's gonna throw it, watch out.
You should throw it.
it was very-
Guys, I've talked to you guys. There's a reason some of you are not being successful. You need to figure this out. You do not want to retake this semester. Do you understand me? Stop doing what you're doing and focus. Okay. You just plot the points that actually fit on the graph. Don't count from the asymptote, please.
Oh, I did that.
So, you don't scale the graph?
You don't have to. You have enough points that fit on here that it's not a big deal.
Don't count from the.
You count from the axes. You don't count from the asymptote.
Okay.
Oh my gosh. Major headache.
right. Tanari, what is my domain? Which is the same thing as all real numbers. What have you noticed about our domain on all of them?
They're the same.
Will it always be the same?
For exponentials and most linears, you are going to always have an all real numbers domain. Because if you think about what the shape of a exponential is, it's either a backwards J or a forwards J. So either way, it's spreading both directions forever. Do you see that? And that's the same as a line. Yeah. Even if it's a line, so my arms are aligned, it's going to go off in both directions forever too. That's why most lines, not all lines, vertical and horizontal are a little bit different. Most lines, domain and range, are also all real numbers every single time.
I don't like
So you guys are aware.
So
All right. That's fine. Brian, what's my range?
Range is 2, infinity.
Yeah, it starts at the asymptote and it goes up forever. So, is -4 on the graph?
no.
What do you guys get when you plug in -4?
83.
Did somebody else get -3?
I said 83.
I was going to say that doesn't make sense at all. Does not equal 17, so no. All right, look at the next example.
I like what you did on the back page where you did the recap.
I didn't make these notes, Miss Wilkinson did. She's very good about doing that stuff. She's awesome.
Is that your random student?
I will tell her during lunch, don't worry. All right.
Little lady.
We don't get tired here.
Not true.
Okay, you can type this one exactly how you see it. Jana, this is like the ones that we worked on, the first day, so see if you can get the answers, okay? Because we kind of did problems just like this the first day. So see what you guys get out. Just make sure you're typing it exactly how you see it. We've practiced putting problems like this in our calculator. When you practiced on that worksheet yesterday too. Where's my asymptote at?
0.
I have 2 questions.
First question.
How do you figure out where that?
You look at what's being added or subtracted at the end of the problem. So this one is adding nothing, so it's adding 0. But if you look at the last one, it's adding 2, so that's why that was there. Does that make sense?
Yeah.
What's your second question?
So we just put it. We just put the equation in exactly how it's on the thing.
Yeah, so you'll literally type 2 parenthesis 3 parenthesis raise it to the -2.
It's spelled so weird.
I know. When you type it into the computer, it doesn't even think it's a word.
I'm just gonna call it cinnamon.
Cinnamon is not even near what it is.
I hope you remember it, 'cause cinnamon's good.
That makes sense. I just
I don't
accidentally.
even know how to spell cinnamon.
I
I think I do that.
I did the cinnamon challenge where you put a
spelling test.
spoonful
That's
of
when
it.
we almost have. I don't even know how to spell.
It wasn't a challenge.
I'm so excited for that one.
See, I'm
What?
not.
What?
Mr. Steinmeier in his lab gives the kids spelling tests. It's hilarious.
Yeah.
I can't spell. I can barely spell that word.
Those are the numbers I got out. Did you get those numbers out?
Yeah.
Did you not? Jana, are you doing okay? I'm sorry, I'm not trying to pick on you. You just have a different calculator. You doing okay so far? Okay. So we can plot our points once we have them. Is this one growth or decay?
Growth.
It is definitely growing.
It's obviously linear.
Yeah.
I think it's linear as well.
Well, just plot the points that fit. 18 obviously does not fit. Are we allowed to cross our asymptote?
No. Are you ever allowed to cross? No.
The cinnamon is an asymptote, and no, you are not.
Okay.
Don't ever say that to any other teacher because they'll have no clue what you're saying. At least I know what you're saying. All right, Josh. What's my domain?
Domain is all real numbers.
an exponential? I don't believe so, but I'm not going to say 100% of the time, but I'm going to say I don't think so, based on like what I've seen. Okay? What? Okay. Riley, what? Riley, can somebody throw something at me, please? Colin, what is the range?
Okay, let's see. I gotta think. I've never been good at range. Good. Okay, so it's going to be, I think. It's 0.
Yes?
Yeah, okay. And then infinity?
Yeah, the asymptote there helps you out, so that's 0 to infinity, so y is greater than 0. What's the equation of the asymptote, Colin, or Connor? I'm just playing musical names right now. No. Where is it at?
0.
0. And what's your question?
Oh, that's it. Oh.
What's your question?
So it's the first row with X in the range, or like whatever. Is that where the asymptote starts?
That's a y value. This is a y value to a y value, and yes, that's the asymptote to infinity.
Okay. So it's the second one always infinity.
And yes, for us. That's not always true, though, guys. Connor asked a good question. Is the second number always infinity? No. The problem is we don't really discuss this much in this class, and you'll talk about it more in Algebra 2, but exponential functions can flip over the asymptote and face downwards. So if that's the case, then it would be negative infinity to the asymptote instead, because it's going down forever until the asymptote for that one, okay? What do you notice about all of these graphs? What is some of the things that is happening in every single graph, Justin?
The domain's the same.
What? Domains are the same. How about the shape of the graph? Did you notice that?
They're all a curved line.
Either in a J or
What are some differences? Because we kind of just did similarities. What are some differences? Yeah.
First number in the range is different.
So the asymptote can change, right? Which is the first number that is, I'm going to write this as the first number in the range. You're right, not wrong.
Yeah, I'm writing cinnamon.
Oh my gosh, brother. So the asymptote is a boundary that the graph gets infinitely close to but does not touch. What type of line is the asymptote every single time? All right. Let me get you guys your homework.